All right, here we go. Okay, give people just a moment to kind of filter in. And all right, cool, here we go. So yeah, today we're going to be talking about functions. So objects yesterday, arrays the day before. Yeah, and these are just all of the kind of the basic value types in JavaScript that you can use. And with functions, it's, I mean, we could do another week-long class just on introductions into, advanced concepts with functions. So there's a lot more to go, but this is just kind of the foundation. These are the basic tools that you need to be able to get in and start, actually building meaningful programs. So these concepts, again, they're very fundamental, and they apply to a lot of other languages. If objects, arrays, and functions like these types of things, or for loops, if statements, variables, like these are present in pretty much every language in some form or another, these same concepts. And so by learning these things, it does put you in a position to be able to go and learn and pick up other languages and other concepts. So anyway, we're gonna dive in. You're gonna have a fewer homework problems tonight because these ones are a little more difficult, but they should be good. It should be fun. All right, let's do a screen share. Okay. All right, so functions. Actually, let me do a. All right. Okay. So a function, you can kind of think of it as like this a black box, and you're going to have some input that comes into it, and then there's going to be an output. So input and output. If you think of in mathematical terms, like in algebra, when you learned about functions, it's a similar idea, the same idea and concept, that we have this this box with a bunch of logic that's kind of hidden away, and we give it some input, and then it gives us some output. So so I worked for a company that we were doing health software, and so one of the functions that I wrote at one point was for calculating your BMI. It was to ultimately make a calorie recommendation, or the number of calories you should eat based off of your weight loss goals or weight gain goals, and then based off of your activity rate and level and stuff like that. And so you have these different inputs, and so these inputs that would come in for this calorie recommendation, one of them is weight. That's smooth out my line. So weight. Another one is for height. So like your weight and height affect your body, well, your BMI, which affects the number of calories you should be consuming. And there's a lot of other factors that go into it, but height and weight and activity level, your goals, and this is being simplified dramatically, but yeah, like there's some other different aspects and things that need to come in, but pretty much like height, weight, activity level, your goals. We'll just keep it to that for right now. So we have these 4 inputs that go into this function, and then its output is the number of calories that you should be consuming in a day. And so it's this idea of, we take this logic and we kind of abstract it away, put it into its own little unit, we give it some input, and it gives us an output. And functions are used everywhere. We use functions all the time in JavaScript. It's just everywhere. So it's a concept that you'll want to become very, very comfortable with, very, very familiar with, because that's how we build our programs. We try to, like, if you have a piece of code that's that's getting reused over and over again, you'll want to move that out, abstract it out into its own function. you try to break your program down into small functions that are composed together to form a larger program, as opposed to just having one file that's just a million lines of code long. You try to break it down into these small units, and it keeps it more organized. It's easier to read it, easier to understand. Something that you're going to discover very quickly is that you will you'll write some code, and very, very quickly you're going to be it becomes insanely complex very, very fast if you are not just almost like stupidly simple with like how you write your code. Like you want to keep it as simple as possible, just the variable names and the way you write it, and you'll start to get a sense for what's simple and what's complex as you get more experience. But it's easy to have your code turn into just like a big ball of spaghetti, and it's impossible to decipher and understand what's going on. And so functions are a way to help us be able to break it out and sort our logic out into these different little pieces that all fit together. So these functions are kind of like Legos, and then we can take all these Legos and put them together and build out our application. Let's see. Thomas is asking, I know this is a bit ahead of where we are at in the current lecture. Are we getting into callback functions? Yes, we are. In a little bit. So high level, this is the idea behind a function. You have some input, and then you have an output. So input and output, and then you have your function, and the function is going to, based off the input, modify it in some way. So in JavaScript, we can have functions that don't have input and they just have output. We can also have functions that don't have either. So maybe they don't have an input that comes in, and then they don't have an output, and they have some set task that they're going to perform. So the function can have an input, it can have an output. Both of them are optional. If it's not giving an output, then it's just going to return undefined by default. It will be using, anyway, so we use the return keyword. I'm going to walk you through it. You've had a lot of experience like within basic functions so far with like all of our homework assignments, just because we use the return keyword. Like all of your tests are inside of a function, like you're making functions work. So you've been exposed to it as we've gone along, so we're not starting totally from zero on it. But anyway, there's the high level idea of what's going on. All right, so let's come back in here. Let's break down functions a little bit and how we actually write them. So let's say function, say hi. All right, so we use the function keyword. This is a keyword just like const and for and let and if. So const, let, for, if, those are all keywords. You can see that the editor turns them blue to indicate that they're keywords. So that means that you can never have a variable called function. That'll break your program. So function says we're creating a function, and then we say the name of the function. This is kind of like the variable name. It's the reference. It's the name that we can use down below to reference the function that's typed in up above. It's created up above. So say hi. All right, and then we have parentheses. So 2 parentheses, and then we have 2 curly braces. So function keyword, the name of the function, parentheses, and then curly braces. Curly braces we break down onto multiple lines like this. But those are the basic pieces that create a function and define a function. So inside of the parentheses, this is where we write the inputs. These are called parameters. We write parameters right here. So the parameters are their variables. You can think of it as like defining a variable that will be used inside of the function. The parameter is only available inside of the function. We can't use it out here. If I tried to set message or something out here, this wouldn't work. We can't see into the function. Your code can't see into functions, but if from inside of the function can see out. So I'll get into that in a little bit. So you have a parameter. You can have a comma-separated list of a bunch of different variable names, parameters, and you can have there's a limit of like 260, I think. But you're not going to be generally. You're only going to have like, I don't know, 1 to 4 parameters. So you're not going to have We're not going to have a ton. So, all right, so we have the input, and then whatever I return is what's going to be returned from the function when I invoke it in the code. So, so for example, so say hi when I invoke this, whatever is specified after the return keyword. So right here, the string hi. Is what the function expression is going to evaluate to, and I'll break that down for you. So to call the function or invoke it, we use two parentheses, and so we specify the variable name that references the function, and then we do an open and close parenthesis, and this right here invokes it. In between these parentheses, we can pass in arguments. So here we call these arguments. Up here we call them parameters. But I'll walk through an example of that in a moment. So if I say const message is equal to this, then what's happening here is as our code is running on line 1, it sees that we define a function here. It does not run the stuff that's in between the curly braces yet. It does not run it. It packages up that block of code, and then we could do like greeting is equal to hi, and then let's return greeting. So you can have many lines of code here, but essentially it packages all of this code up here into this little box, and the box's name is say hi. So if we come down here to line 6, then we read it from left to right. We're going to create a variable called message, and we're going to set it equal to the result of invoking say hi. So say hi again, when the system sees this, it runs up, finds the say hi variable, it grabs this block of code, and it invokes it. That's what the parentheses do. The parentheses specify that we are invoking the function at this time. So we invoke the function returns something, and then when it's when we return it right here, so we return the greeting, then that's what this right here, this line is at runtime going to be set equal to the string hi. And so message is then going to be set to the string hi. That's essentially what that invocation is doing right there. And then if we do console.log message like that, so if we run this, we'll see that hi is printed out. So again, this function is defined. We come down here, we invoke it. We get the message, the result of the function, or whatever is returned right here, is what this right here will evaluate to. And so it's going to evaluate to this string. That's going to be assigned to the message variable, and then we're going to log out the message. So this right here is just this basic flow right here is one of the fundamental concepts of JavaScript, one of the most important things to start to get down, just this idea of functions and calling them, and they return a value, and then we can do stuff with that value. Okay. Let's see. Ben, can you comment out your code instead of deleting it and post it afterwards for reference? Yeah, I could copy. I'll copy some snippets and post them into Slack. So I'll do that as we go along. I'll do a little bit of it. You can rewind the video to view things. So if there's a piece that you want to see again, feel free to just like pause and rewind. Okay, and then the recording is available afterwards as well for you to go in. Okay. All right, 1 second. Okay. So yeah, let's see. Yeah, I'll paste some of the snippets in. Okay. All right, so another thing let's talk about here. So here's a simple little function, calling it foo, just going to return some string. And so if I do const bar is equal to foo like this. And if I console log this, if I log this out into the console, then we see here that the actual function is invoked. So super common mistake that we see just in the beginning when people are learning about functions is this idea of in the definition of the function versus invoking it. Right here, I set another variable to refer to the same function. And so bar and foo will now both be variables that point to the same function. That's what this line is doing here. This is not going, bar is not going to be set to high, it's going to be set to the entire function. And so if I invoke bar right here, print that out, then we see the string high is printed out into the console. So it's just important to remember that you need to have your parentheses there. All right, so let's do other functions. So we're going to call this multiply. All right, so right here, we have a function. It takes in two inputs, and we're going to multiply these two inputs together, and we're going to return the product. Product is going to be equal to multiplying or calling multiply log out product. Okay, so x and y, we have two parameters that are specified here. So now we can pass in two arguments there. Let's do 5 and 5. Here, what we do is go return 5 times 5. Well, not 5, sorry, x times y. So this is going to, so we're going to take the two parameters and we're going to multiply them together and then return it. And so the important thing to note right here in this example is the idea of we pass in input and then they get passed through this. It's like a template. The function is like this template code, and these inputs can change, and the function can be reused. So I could say const product 2 is equal to multiply, and then let's do 10 and 10. And then I could do const product 3 is equal to multiply 15 and 30. So product 2, product 3. And so you can see here that the function can be reused. The function can be reused multiple times. So now as we run this, let's say product 3, produce. All right, so if we run this now, we see 25, 100, and 450 are passed out, are printed out. So the function can be reused multiple times. We can pass in different arguments. So that's why we call this, yeah, there's about a 20-second delay. So yeah, so there's a lot of, so we have some arguments that are specified that are coming in here. And the arguments can change. The parameters don't. The parameters are placeholders. They're variable names. They refer to the arguments that are being passed in, and then we can do work with them, and we can do any number of things inside of here. From outside here, lines 5 through 7, they don't need to know what the inside of multiply is like. We don't need to know what's going on inside of the function. We just know that if we give it two numbers from the outside, it's going to give us an output. It's this idea of a black box. And so we pass stuff into the function, and then we return a value. Let's see. Okay. All right. Okay. It doesn't throw an error when you pass extra parameters. So extra arguments. If we pass in extra arguments, it doesn't make an issue, like that just doesn't break anything in JavaScript. In other languages, that can cause an issue. JavaScript is pretty loose with that. And so these other arguments are coming in, they just don't get used inside of the function. All right. So there's a couple different ways that we can define functions. Well, actually, before we do that, let's see. Let's start talking about, we're going to talk about methods now. So let's say we have a user object here. Okay, so we have user object, and then we'll have, name is Ben. We'll do an email. Have an email, and then we'll say password. So, so right now we let's see. Oh yeah, so comment about arguments. Yeah, so there is an arguments array that is present inside of the function that you can reference. It's a pseudo array, doesn't have all the same methods in it, and you need to use a lowercase a. But we'll talk about that in a little bit. So we have our email, password, and then now we can add a method to it. So we can call this check password, and we are attaching a function to the object. So again, we talked about this a little bit yesterday, but this method is just a function that is attached to the object. It behaves the same way. You just invoke it a little bit differently. So what we'll do is we'll say return this dot password equals potential password. All right, so if I do user dot check password, and then we'll say FDSA, say const result. Now let's print that out. So if we run this, we see that false is printed out because they do not equal. If I do ASDF, we're going to see true. And so we use, again, it's the dot notation. We reference the user object, and then I invoke invoke in the same thing. We call check password that's on the object, the function there. We use parentheses on it. We invoke it. So it's all the same. It's just the way that we target it. We use user dot. And then that's where the function is contained. The function is attached to this object. It is not floating in space. If I just try to do this, just try to do check password, then we're going to get an error. So it's attached to the object. So again, functions on objects, we generally refer to these as methods. And so this is a method on the object. And so so anyway, the objects, again, it's this idea of being able to package together different data types into one cohesive unit. So we have, strings for email and password. Maybe there's numbers and other, arrays and other values. And then there's also logic that we can attach to the object in the form of this function, this method. So yeah, so again, objects are a way of grouping together different types into one cohesive unit. Okay. All right, let's take a look at the arguments array. Okay. So there is an array, and it's a limited array. It doesn't have all the same methods attached to it. But there is a keyword that is present in all functions that is called arguments. And it's a special array that is filled up with all the parameters that are being passed in, or all the arguments that are being passed into the function, regardless of whether or not there's parameters referring to those. And so if I do foo and I invoke this, we're going to see, well, they're printing it out as an object, but if we do, let's see, hi, null, true, false, 15, array, object, just a bunch of different random values. If we print that out, we see that they're all printed out, and it's written as an object, which is a little bit, a little bit funny, but it is different. It's different from the arguments is a little bit different from standard arrays. It has a length property on it, but there is no push or pop or shift or unshift or slice or splice like or any of the other methods on it that are on arrays, but there is a length property. And so, you can use this in a way to be able to handle a dynamic number of arguments, depending on the way that you're writing your code. Most of the time, you're not using it, and you're generally kind of staying away from that. But there are some times, and some libraries will make use of this, and with creating some different helpers and things like that. So this doesn't come up very often. You don't use it hardly ever. I don't think I've actually ever used this in production code ever. And so it comes up in interviews, and you see it sometimes, and it's good to know about it. But you're not doing that very often. And I would almost think of it as like a bad practice to write your functions that way. But it depends on the circumstance, and there are times where it would be useful. You just don't use it very often. Okay, so functions are the thing about functions in JavaScript is that let's see. Yeah, I'm actually not super familiar with Java, but I would imagine that the Java args, I would imagine that that's probably the same idea. I haven't done a ton of programming with Java, so off the top of my head, I'm not sure. I'd have to look that up. So so functions in JavaScript, they behave in very similar ways to other values, in the sense that you can do the same things with functions that you can do with other values like numbers and strings. You can pass them around, you can transport them around in the same ways. And so for example, you can fill up an array full of functions. You can put functions on objects. We call them methods. You can pass functions into other functions, and functions can return functions. And so a function, this block of logic, can be passed around, and you can start to do some crazy things with it. This can lead into some more advanced patterns, and these types of patterns are being used more and more with JavaScript. And JavaScript is being defined as is often being used in a very functional way, or a functional programming language, a language that's more oriented towards functions. And anyway, we'll talk a little bit more about that later. We go into that in a lot more depth during the course. So I'm going to show you a couple different examples of that, and I'm going to show you a couple different ways you can write functions. So you can write your functions as this is called a function expression. So here's two ways you can write this. I'm going to talk about arrow functions in a little bit too. This one doesn't use a semicolon, but so foo right here, this is called a function expression. It's an expression because there is a single equal sign. There's an assignment being made. We are taking what's called an anonymous function right here, and we are assigning it to the variable foo. The variable foo refers to this anonymous function. And so this gets used, this is one pattern that gets used. And then this right here is a function declaration. Let's see. Okay, so Eric's asking, is there a reason why arguments returns a string? Returns it as an array. Do you mean something like that? That's what you're referring to, like the ES6 feature with your 3 dots? If so, we can talk about that. We'll talk about that a little bit later. Because there's a way you can. Anyway, we'll talk about that later. So, all right. So with so there's a function. All right. So function expression, function declaration. The main use case difference here, it has to do with hoisting, which is a more advanced concept that again we talk about later. But function declarations can be used before they're before they're declared. So this right here works. This is valid code. But function expressions, you can only use them after the point in the code in which they're written. So if I tried to invoke foo right here, this right here would create an error. But here I can, here, so you can even see it gives me a warning sign. Foo was used before it was declared, which is illegal for const variables. So, and if I used var, it would behave the same way. It would just be it's not warning me on it, but it was warning me about the const. But this right here will say like cannot invoke like undefined, because foo will, the variable works because it gets hoisted, but it will be undefined. So I'm not going to go into hoisting in depth right now. We have some blog posts about it on our site, but just basically what it means is that when you use a function expression, you have to invoke it after it's written. A function declaration can be invoked before it's written. Generally, it's considered best practice to only invoke a function down below anyway, but I would suggest just using function declarations for writing your code like this, unless we're using arrow functions, which we'll talk about in a moment. So these are some different, anyway, so here's some different ways that you can write some of this stuff. So okay, let's see. Eric threw in a little code example. So if we look at this example, well, let's see. Actually, I'm going to hold off on this for a little bit. I don't want to go into the spread and the rest operator yet with ES6, but I'm going to keep talking about how we can, about functions as first class values. So I can do, so const foo, so this equal to a function. So I have this function right here. It's anonymous. It doesn't have a name to it. And so this function, I'm assigning it to the variable foo. And so this is the same kind of thing that's going on when I say const x is equal to 5. So I have a value that I'm assigning to a variable. Here I am assigning a function to this variable. So it's the same concept. So functions can be assigned to variables and referenced by variables. I could say, so here's function foo, here's function bar. They're not doing anything, but what I can do though is I could say const functions, make this an array, and I can say functions.push foo and bar. Then console.log functions, and we print that out, and we'll see there's 2 functions that are inside of the array. And so you can fill up arrays with functions. And again, the purpose of this is to illustrate this idea that functions can be passed around. It's like this little unit of code that can be passed around. You can do interesting things with it. So if I were to do, so this leads into the idea of a callback function, which is something that would have been Eric. Someone asked about them a little bit earlier. Oh, it was Thomas. Thomas asked about it. So we're going to talk about callback functions now. So a callback function is the idea that we can take a function and pass it into another function, and then the other function that we pass it into invokes it and calls it later. So function foo is going to have a parameter for another function. And then we're just going to invoke it inside of here. We're just going to invoke whatever function gets passed in. So now down below, we can do this. We have foo. And then we can write this function. We actually define the entire function block in between the parentheses. This is a very, very common pattern where you have this function that's highlighted in blue defined in between. The actual definition is written in between the parentheses. It doesn't have to be. I could say, I could define this up here, and I could pass it in like this. Like, that's fine. It behaves the same way. I'm just going to write it in line like this so you can start getting used to seeing functions written this way. So again, it's this, everything that's in blue, that's this one cohesive like block, this one function, and we are defining it inside of the parentheses. So when we invoke foo, this function is going to be passed in. And then we're going to be referencing it by the variable cb, and then we're going to call it right here on line 2. So this is starting to get a little funny. This is going to look a little bit different. And we can, invoke it multiple times and say, different things. different, have different logic that's getting passed in. But we run this and we see these messages are printed out because these three functions, this one, and this one, they're being defined as we invoke foo, and then they're being referenced by the variable cb, the parameter cb inside of function foo. And so we're literally passing in a function into foo. This is conceptually, like, this is no different from saying like if we were to have like let's say a function say log message, and in here if we do console.log message, like there's nothing like conceptually different between those. Like we're right here, we're writing a string, we're defining it in line, it gets passed in, referenced by the parameter, and then we're logging it out. Here we define a function in line, it gets passed in, referenced by the CB parameter, and then we invoke it on line 2, just as if this function had been assigned the variable name CB and we're invoking it. So this is something that we practice quite a bit in the course. This is something that you'll be use callbacks everywhere. It's especially when you start getting into libraries and when you get into backend development with Node and Express, you're just using functions and callback functions absolutely everywhere. And it's something that gets a little better. It takes some practice. You need to start getting the muscle memory, getting the reps. But that's when these concepts can start to really stick. And something we can do here as well, I could say message on these. I'm gonna remove this part of it. So I'm gonna change up these functions real quick. So I could pass in arguments. When I invoke CB, it's just like a normal function invocation. I can pass in, so I'll say ni hao. So if I run this, we see ni hao is printed out 3 times because we invoke foo, we pass it in a function. When we invoke that function, we pass in an argument. So ni hao is referenced by this parameter right here. We pass it into the console.log. It prints out in the console. We run that 3 times. So it's and so this can be a little tricky at first, but it really is a pretty simple concept. It's just the idea of we're just passing in functions, and then they get invoked, and they get called later. And so callback functions, we use these all the time. In fact, here's an interesting use case for one. So if we were to let's see, let's do numbers, make an array. So 1, 2, 3, 4, 5, and there's a common array method that we use that is a common array method that's used that we use in place of a for loop as you get more advanced, and this is something that we recommend that's used that you use in place of your standard for loops. And what that looks like is we go numbers. There's a for each method on the array, and we invoke it. So method is a function attached to the array. So we invoke it, and it expects a callback function. So we're going to define the function in line like this. So usually when you're using a callback function, it's an anonymous function that we're passing in. In some languages, this is referred to as a Lambda function. And so that's where the idea of a Lambda, like Lambda school, Lambda function, it's a key functional programming concept. But so this anonymous function, again, we call it anonymous because there's no keyword, there's no name to it, there's no variable associated with it. Essentially, it's kind of like a one-time use function. but we pass in this function, it has a parameter for the number, and then this callback function behind the scenes is going to be invoked with each item in the array going from left to right. So as I run this, we see 1, 2, 3, 4, 5 is printed out. It's because this function right here gets called, it will be called 5 times, and these numbers will be passed in from left to right. So that's what for each does, the for each method on an array. And this is the ideal way to iterate over an array if you just need to do a standard left to right iteration and you don't need to do anything fancy, you don't need to go backwards, you don't need to skip numbers. And so this is something that we eventually recommend. And you don't have to switch 100% to this right now, but this is something that eventually we'll be having you do. But the point of this right here is just to show that we have a method that we're invoking. We're giving it a callback function. And that callback function is being run on all the items in the array. So there's another one, another really common one. It's called map. So I'm going to do call this const map to values. And for each doesn't return anything. The for each method doesn't return anything. We don't want it to return anything. But in map we do. And map is going to produce a new array. And so it's going to give us each one of these numbers from left to right, just like in for each. But if I return, but whatever I return from inside of this callback function is going to be assigned into the corresponding slot in the new array that's being produced. So right here, return num times 2 is going to produce another array where each item is going to be doubled in it. So if we clear this, and I gotta log it out. We run that, we see 2, 4, 6, 8, and 10 are printed out. And so this callback function, again, is getting invoked by the JavaScript code behind the scenes. This function right here that's in blue is going to be invoked for each item inside of the array. So it'll be invoked for each one. Each item is passed in turn, and then we return an item. Whatever we return is going to be stuck into that slot inside of the array. So if I were to just do, like return high like that, then the array is just going to have 5 highs in it. But if I do anyway, num times num, square all the numbers. So anyway, that's how map works. So I'm taking a moment to explain these because you're actually going to be replicating these in your homework. Let's see. Yeah, so we are going to be getting into arrow functions in a moment. Yeah. So in ES6, so functions, it is different from var. So we told you don't use var anymore, but use const and let. Within this, that same logic does not apply to functions. There are times when you have to use the function keyword. So the times when we have to use the function keyword are when we need the keyword this. But anyway, I should probably explain arrow functions first before we get into that. But there are times where you need to use the function keyword. Okay. So okay. So one more thing I'm going to cover before we get into arrow functions. All right. So we saw how functions can receive other functions as an argument when they're invoked. We can also return functions. So right here we are returning a function. So function foo gets invoked, and then what it returns, what it gives back, is another separate function. And so say hi like that. So if I invoke foo, it's going to return a function will be assigned to the variable bar. I can then invoke that function that was returned here, like this. So if we run that, see hi is printed out. So this idea that we can return functions is a fairly powerful concept. There are some different patterns that come about from this. This foo is referred to as a higher order function because it can be used to create another function. We can create different types of caching, like memcache type things, and so this is very much just me just kind of showing you that this exists, so this can be there in the back of your mind, so that way later when you encounter it again, it's something that you can practice more down the road and get in a little more depth. But so I'm covering a lot. There's a lot of stuff that I'm covering today in this lesson. It's just kind of a inch deep, mile wide kind of a thing. And then as you have more questions about these specific concepts, you can come back in and ask them, and we can iterate and and then inside of the questions channel we can address those misunderstandings that will certainly be there. Okay. So this function, we're going to return it. We can invoke it like that. Often you'll see it invoked directly so right here, actually, let me put the console.log back in. So we are returning, or we're just logging hi. And so if we invoke this right here, this is going to return a function, and then we can immediately invoke it. This other set of parentheses. So now if we run this, we see that hi is still printed. That's because foo is defined. Then we come down here, we invoke foo. Foo returns a function. So this part right here essentially is replaced by this function, and then we immediately call it right here. We can pass in parameters and arguments, just the same way. We can some of the interesting patterns occur when we start passing stuff down through the original function. So for example, this doesn't need a semicolon on it, but so function multiply, let's say multiply by x, and then it's going to take in x, and we're going to return a function that will take in another parameter, and then we're going to go return x times y. Now what I can do is I can say const multiply by 5 is equal to multiply by x, and I pass in the number 5. And now I can do multiply by 5, and then I can pass in another 5. And I'll walk through this in just a moment. But right here, what this does now is we see that 25 is printed out. So what's happening, this product is the result of multiply 5 and then by 5. And so on line 7, when we call multiply by x, 5 is passed in as an argument. And so x right here is 5. We then come down in and we return this function. And so line 7, multiply by 5, the variable refers to this function that is highlighted in blue. We come down here, line 9, const product is equal to multiply by 5. So we call this function. So it's going to go back up and call it. And then we're going to pass in 5. So 5 is going to be y that's going to come in. And so down here, we say return x times y. It's going to go back to its parent scope, find the 5, and then it's going to, and then it can properly generate the expression. So 5 times 5. Okay. So it's this, this idea that we can you can have these like, it's like these like settings almost, and you can kind of compose these unique functions based off of different properties or different options that are passed in. And this is a common pattern that you see when you get into React and Redux development, as well as Node and Express in the server and in the back end. And so this is, again, is another concept that we're just, like, my intent right now is just to kind of introduce you to this a little bit. So this is something that won't be 100% new when we start practicing with it more and start working on it, going into it more in depth. But essentially, it's just the idea that a function can return a function, and then the function that's returned can go back in and look at its parent scope and access parameters and variables in that scope. It's actually called closure. If you've heard of what closure is, this is closure. This gets asked about in a lot of interviews. It's a very common like area of misunderstanding within JavaScript. A lot of developers don't totally understand how this works, and so it's important to know. It's maybe not maybe not the top of your priority list at the moment, but eventually this is something that you will need to master. Okay. All right, let's talk about arrow functions. So in ES6, so again, ES5, ES6, ES6 is a new version of JavaScript, and there are some different keywords, different things that are in it that we are not able to use in previous versions. ES5, the language is improving and updating as we go along. And again, just Babel.js under Learn ES 2015. ES 2015 is the same as ES6. It's two different terms for it. But this goes over a lot of the different, some of the things that we've talked about, like the like template strings and constant let, and we talked about enhanced object literals and just some other stuff. We're going to get into arrow functions. Those are some of the big main ones that you're using a lot. Classes is another one that we teach towards the beginning of the course. That's we'll go over constructors and stuff like that. But anyway, so Learn ES 2015. You can go in and kind of use that as a reference for some of these things as well. If you're totally new to JavaScript, then it's not a big deal probably to reference this right now. But just do what you're seeing. If you have some experience, if you have some experience with stuff coming into this, like JavaScript coming into this, then this can help kind of explain the differences between the two and show examples. So, okay, so arrow functions. So in ES6, we have a simplified syntax for how to write functions. They're a little bit different from normal functions that we define with our but besides just the syntax, their behavior is a little bit different too. The main difference is that in arrow functions, there is no this keyword. It is not set. There is no arguments array either. So arguments and this are not present inside of an arrow function. If there is this that you're accessing, it's because it's looking into maybe a containing function, or it's looking into the global this object, which refers to the window. So this in arguments is not set. It's not bound when you're using an arrow function. That being said, it's other than that, just so keep that edge case in the back of your mind. That won't be important for our homework and stuff today, but in the future there are times when that's important. And so arrow functions, again, it's a shorthand syntax for defining a function. So let's do input, and then let's see. So let me do the multiply example. So let's do const multiply is equal to x and y. And so then we can do multiply 5 by 10. Turn that out. Let's say return x times y. And as we run that, we see 50 is printed out into the browser. So it behaves the same way, just a little bit of a shortcut here. Kind of cuts down. We have this, we call this a fat arrow, where you have the equal sign and then you have the greater than sign. And so that's kind of the stand-in for the function keyword. There's a couple other differences too. Let's say that we call this square. So we're just going to square the number. So we only have one parameter, and we're going to return x times x. So we'll just pass in one argument, run this, square, run this. We see 25 is printed out. We can set, and this isn't specific to arrow functions, but you can set a default value. So I could set like a default value of 7 if that was important to me for whatever reason. And so if I don't pass in an argument, the parameter is going to be assigned a default value of 7 right there. So it's going to return 49. But if I pass in 10, then it returns 100. And so there's a default parameter. This is another ES6 feature. This is not available in ES5, but ES6 is implemented. This is implemented pretty well now. Like this will run in Chrome if you're dropping these code snippets into the browser. Okay. So the next thing I wanted to show you. So if we just have XX like this, there's another simplification we can do. If you have a single parameter, you don't have to put parentheses around it. So if we run this, it works. So you'll see 25. So, and then it's common to have simple functions that you're creating that only have a single line in them. And so you're just returning some simple operation that you're doing. So like this, this comes up from time to time. And so there's a way to simplify that even further. So if we get rid of these curly braces and the return statement and move it up onto the same line, it's going to automatically inject a return statement. So right here, square is equal to x, arrow x times x. We run this, we see 25 is printed out. And so if you have a very, very simple function, like you're squaring a number, something like this, you can do a, anyway, you can pass, you can remove the return statement. You have to get rid of the curly braces in order to do this, but it allows you to put it onto a single line. So you might need you would need parentheses to set a default parameter. So probably set it to like 0. So if nothing was passed in, then we'll just return 0. So yeah, you'd have to have parentheses there because then otherwise it's gonna not know how to parse that. So, but yeah, so if you set a default parameter, or if you need to have multiple parameters, then you need to have it in parentheses. But so it's mainly just it's a shortcut. So another major use case for it, if we do const nums is equal to 1, 2, 3, 4, and 5. Let's do nums dot for each again. You'll pass in arrow functions as callbacks. This is a super common way to do it. And so, so n, and then we'll do console.log n like that. So this is super common. We could put it onto the same line if we wanted as well. Clear and run this, you'll see nums.forEach, and then this is just a simplified little function. We get n in, and then we pass it into the console.log. So this is so these are the major use cases for arrow functions. They simplify and cut down on the way that you write callbacks. So like, yeah, your callback functions that you're writing, or methods on objects, and it can make it really simple, really easy to write just very, very simple and basic functions. So you might be wondering, okay, so we've seen a couple different ways to write functions. Which way should we use? Which way should we default to? So different developers will say different things. Different companies will have different practices and style guidelines regarding this. It seems like most now are suggesting to always use arrow functions unless you can't use them. And the times when you can't use an arrow function is when you need to use the this keyword. So if you need this keyword, then you use the function keyword. So then you would use a function declaration. Otherwise, you should write your functions like this. So this should be the default. So this is what I recommend you write your functions in. But in Replit, inside of Replit, it will not work with arrow functions. It has to do with the way that the functions are bound and the way that they're passed around and the way that they are injected into the testing framework. And so those functions have to use function declarations. Otherwise, those all would have been written as arrow functions, but it doesn't work that way. And so just the way that Replit is set up. So they're all using function declarations, which is fine. But this way is preferable if you can use it. So default to this second one. If I mutate the nums array from my previous example, let's see. Yeah, let's see. So let's see. What if you mutate the nums array? So what do you mean by mutating the original array? So by default, like for each and map and reduce and those other methods, they will not modify the original array. That's very much intentional. So it's instead of modifying the original, it's producing a copy. So for each doesn't do any type of modification or anything of the original array that it's on. It doesn't produce a new array. So you can modify it, I guess, as you go along. So yeah, so if we did n, and then we have I for the index, and then this would be the array collection. Generally, like you want to be careful with modifying the array as you're iterating through it, but maybe there's some specific thing you're wanting to do there, but you're hardly ever using this third parameter inside of for each. Mainly using the first one. Sometimes you need to use the second one. Like within React, sometimes you need the index for setting keys on React components. But let's see, arrow functions all through Replit. So Thomas, have you been replacing the existing functions that have been written with arrow functions? Because if you're replacing it and it's working, then maybe they updated it. So because that wasn't working for me a few weeks ago. So they're constantly updating it and changing things. So maybe it's working now, but yeah, that was not working for any of our tests a little bit ago. Okay, so I'm just happy to answer questions right now. If you guys want to drop questions into the questions channel. Let's see. Yeah, no more snippets. I have like a list of concepts that are my notes, but all these examples, I've taught this so many times. I just come up with these examples on the fly. And I do all this coding on, so I don't have like a list of snippets that I'm like copying in here. This is me just coding from scratch. Yeah, if there's any that I didn't paste in or like little modifications that I made as I was teaching, I would just suggest you go back and rewatch those portions of the lecture as needed. See, okay, so for Thomas, yeah, that works totally fine. Yeah, so arrow functions do work inside of Replit. Just the outer function the outer function cannot be an arrow function. So if you changed the increment by 1 on line 1 to be an arrow function, then it would break the test. So all the tests would break. So yeah, you can use arrow functions like inside, but that outer function, the one that's being injected into the tests, that one needs to be using a function keyword. So right there you have it like, because it's like mixed, like you're using the arrow function for your callback, but then on line 1, you like the outer function is written using the function keyword, and so that still works. But yeah, no, I would encourage you to use arrow functions inside of the functions that are already written for you. So. Is return needed in that case? I'm sorry, in what case? Because there's a little bit of a delay, so I'm not sure which thing that I said you're referring to. And then Sandra, in reference to your snippet that you just posted, let's see. So you're probably getting like undefined or something weird printing out on line 1. And that's because nums.forEach, the for each doesn't return anything. So like let's see, yeah, Thomas's example. Yeah, so in Thomas's example, we do. You need a return there because array.map returns an array. I'm pretty sure this doesn't return anything. You're never really using it in that way. It might return like the original array or something, but yeah, undefined. So yeah, for each does not return anything by default. So like the result of invoking for each does not return anything. Map does. Map, reduce, filter, those do return things, but for each does not return anything. For each is just going to call each item in the array with the callback that you give it. Okay, so let's see, asking a question about a ternary operator. I think one of my solutions in one of the homework assignments talks about a ternary operator. Const const age is equal to 20, and then we'll say const can drive is equal to, and then so a ternary operator. And often ternary operators are kind of frowned upon because they make the code a little more difficult to read and understand. And so this is something where like initially like having fewer lines of code doesn't necessarily mean it's better. The code should be clear and easy to read and easy to understand, and that is the most important thing to optimize for. And so ternary operators or long Boolean expressions, those can be incredibly difficult to reason about. And so so this is what a ternary operator is, but like you don't, it's something where generally you can kind of stay away from it. But it's important to know how to read it, and there are some instances where it's good, but generally it's like you don't need to just throw it in everywhere. So if const age is equal to 20, and if we do, there's 3 parts to it. So let's say age greater than or equal to 16, and then we'll say true or false. And I'll walk through this in just a moment. So if we run this right here, it's going to print out true. And so what this is, when you're doing an assignment like this, an assignment for a variable, a ternary operator allows you to essentially create like a simplified if statement. So right here, this is the if part. So if age is less than or equal to 16, and then we have our question mark. So this is like the if part. then assign it the value of true. So if this is true, then assign this whole expression. This whole expression should evaluate to whatever is to the left of the colon. If this expression is false, the entire expression should evaluate to whatever is to the right of the colon. So I could say, let's see, old enough. I could say too young. So if we run this, we see old enough, change the age to 15 and run it. We see too young. So those are the basics of how a ternary operator works. If you are doing a ternary and then you're doing true and false, you actually don't need to use a ternary operator. You can actually simplify. You can actually get rid of the true, false, and everything, and just leave the expression. So it's actually unnecessary to have all the other stuff, because if I say age greater than or equal to 16, this right here is going to evaluate to either true or false. And so if I run this, we see false. I change this age to 20. It's going to be true already. And so, so you never need to use a ternary operator if you're having like colon true false at the end. So if you're doing this, that's redundant. So your expression right here will evaluate to true or false generally. And so like if you ever have like a true colon false, generally you don't need to do that. So yeah, ternary operators, you'll see these out in the wild, see them on Stack Overflow and stuff like that. But it's something you don't need to go into. And I said, like, don't focus on functions, callback functions, and stuff like that a little more right now. But yeah, the ternary operators are like, they can be useful and they can be good. You just have to be careful not to overly complicate the code. So yeah, so we looked at, I'll just copy in your code snippet. Let's see, is greater than 20. So I'm just gonna clear out these comments real quick just to okay. So this first one is greater than 20. So this one right here. So nums, I think you're wanting to filter and get all the numbers that are greater than 20. So like is n greater than 20, then return it. And so you could use a filter here. So a filter, and this will actually give you the same thing. And so you actually don't need to wrap these in console logs because you're doing the console log inside of your because you're doing the console log inside of here. But if we run that, then that gives us the numbers that are bigger than 20. So filter returns another array. Whereas so filter is doing what you were intending it to do. Oh, just detect if a single value of the array. Yeah, you probably actually want to use just a normal for loop there. So I would do reason for that is if because in this kind of an instance, you can use this return to trigger an early like an early exit of the function. And so because you're just wanting to return true. And so can I duplicate it? Yes. And so this one, let's see, second one returned undefined. Oh yeah, so at the end of it, let's say false. So this is one way you could do it. If you really wanted to do this with a for each, if you really wanted to do this with a for each, then you would just have like a separate variable outside of it. So there's one way you can solve that. Yeah, good questions. Okay, Eric, since you're using high order functions right now, could you briefly explain how array.sort works? I read it on MDM, still a little confused. What makes it sort? So, so with sort, I have to look it up too. I haven't used it in a long time. There's like, we teach you a whole bunch of different sorting algorithms, and there's a lot that goes into sorting, but just by default, it will sort alphabetically and numerically. But if you wanted to apply some custom type of sort to it, then yes, I think it uses a, let's see, Unicode numbers come before uppercase letters, and so yeah, based off of the Unicode, that's how it sorts it. And I think the algorithm it uses is like a quick sort, but there's different types of sorting algorithms that can different speeds, and there's a lot that goes to that. But so I think yeah, so yeah, so sort description. If there's a compare function is supplied, the array elements are sorted according to the return value of the compare function. If A and B are two elements being compared, then if compare AB is less than 0, sort A to an index lower than B. If AB returns 0, leave A and B unchanged with respect to each other. So this right here defines A and B. And so again, if you return a negative number from the callback, like when it's invoked, A is put to the left of B. If it returns 0, leave A and B unchanged. If the compare function AB is greater than 0, sort B to a lower index than A. So return 0 to keep them in the same order. Return a negative number to put A before B. Return a positive number, then B should be lower than A. And then let's see. Yeah, so, and then, yeah, it needs to be consistent. But, yeah, so, yeah, MDN, they have some really good examples in here. This is where I was for looking at this. I don't want to dive into this too deep right now, just because we've already gone about 20 minutes over. But let's see. Yeah, I think we'll call it there. But I'm glad you're looking. I'm really, really glad you're looking at MDM, because MDN is a fantastic resource for JavaScript. Okay. All right. So, all right. Everyone who finishes all the, oh yeah, you're welcome. Glad you appreciated it. It's fun stuff. It's fun to get into this and start learning it. And JavaScript is kind of the first thing you need to learn to be able to then start. Because then there's all these libraries and tools you can use to put it into a very practical format, so you can get it into a very like you can start actually building stuff with your code. So. Fun stuff. Glad to have you all here. Glad that you guys could all attend this. We're going to be doing these types of things fairly regularly, and just wanting to spend time. We want to take a little more of a hands-on approach, helping people prepare for class. Now that we have a little bit more manpower, want to be able to help people more in the preparation process. So yeah. So for everyone, when you finish this, We would like to, if you're interested in our course, we would like to invite you for a phone interview next week. So again, if you're interested in our October class, do everything you can to get this all finished up, by this weekend, and then next week we can have you come in for or call you for a phone interview. So we referenced Replit. We have your email on Replit, and so we go in and we check that and we verify that you've completed all of the different assignments, and so we use that as just a way to make sure that everyone coming into our class is at least on, has a little bit of a foundation with JavaScript. We're not having to start totally from zero. This also allows us to filter for, or it gives you a chance to, experiment and see if this is something that you actually enjoy doing. Because there's a lot of people that will start out thinking, oh yeah, I want to learn how to code, and then, once they get into it a couple hours, they find that it's not something that they really love. And so hopefully this is enough time and enough effort that's required of you to where, you can find out if this is something that you enjoy before you, embark onto a larger time commitment that's much more significant. Okay. All right. Well, thanks everyone. It's been great teaching you, and I'll see you in Slack. Oh, I see Rashmi saying, how do we tell you that we completed required work for the interview? We are just modifying that process. I'll be announcing Austin. Oh, it looks like Austin's on it. Austin's typing some stuff. So yeah, just yeah, Austin will let you know. We're working on automating this and getting a better submission form, but it's not 100% at this point. So okay. Thanks everyone. Have a great night.